Hey there, class. Mr. Husky here. Hope you're having a good day so far. This is 10.5, which is applying other angle relationships in circles. Our essential question is how do we find angles inside, outside, or on a circle? So yeah, let's go ahead and get into this here. So in this theorem, kind of like when we have an inscribed angle, kind of similar vibes here. So in this box here, it says basically, if a tangent and a chord intersect at a point on a circle, then the measure of each angle formed is 1/2 the measure of its intercepted arc. So kind of the same thing we did before. That's kind of hard to read there. Sorry about that. Let's fix that. Measure of AB would be equal to angle 1, and the measure of arc ACB, 1/2 of that would be angle 2. So yeah, so like this one's the red one there. The first one, angle 2 would be this arc right here, okay? Apologies if it's kind of hard to read here a little bit. This technology I haven't used for a little while here, so trying to get reacquainted with it. So in general, kind of the same thing like with inscribed angles. The angle equals 1/2 the arc, or the arc over 2. And the arc equals 2 times the angle. Okay. So some of these circle type relationships, sometimes you have to kind of like find a different arc to kind of figure out what the rest of the circle is going to be. Kind of depends, but let's go ahead and give this a try here, okay? So for number 1, we're looking for angle 1 here. So we're looking for this angle, okay? The arc that intercepts it is this one right here, right? It kind of intercepts that angle. So it is 132. Is that going to be the arc or is that going to be the angle? That's going to be the arc, okay? So we're looking for measure of angle 1. And is that going to be half or double 132? Well, we know the angle is half the arc, so we would do half of 132. And in this case, that would be 66 degrees. Nice. And that'd be our answer. Okay. Always feel free to pause this video and give it a try if you would like. Yeah, sounds good. For B here, so for this one, we're looking for measure of arc EFD, which is EFD is this one right here. And in this case, we actually know the angle right here that intercepts it, which is 110. So we're looking for this arc over here. Is that going to be double or half? It's going to be double, right? So we would do measure of arc EFD. It's going to be double that angle, just like inscribed angles from before. And so that will be equal to 220 degrees. And there we go. All right, sounds good. A little bit more tricky. Not super tricky, but can be. We'll go ahead and do this here, okay? So we have angles that meet inside the circle. We're trying to figure out kind of their relationship, okay? So we're going to do, we'll actually use some different colors here, all right? So we have this angle 1 right here. I'm going to kind of highlight this arc and this arc. I'm going to call this A and B. And then we'll use green, and I'll say we have this arc and this arc, and we'll call that X and Y, okay? So when this angle meets inside the circle like this, there's kind of like intercepting, I guess, chords. The trick is it's going to be kind of similar to the last one, but not exactly. Angle 1 is going to be half of measure of arc DC plus measure of arc AB. We'll make a little bit of an easier kind of thing here in a bit here, okay? And similar for angle 2, it's going to be 1/2 of measure of BC, that arc, and also AD. Okay, but a little bit easier way to say this, we'll use the same colors here. Angle 1 is going to equal half of A plus B and angle 2. So basically, like whatever angle it is. So for angle 1, it was right here, and that kind of lines up with, it's kind of the angles of the arcs that line up with that angle, kind of across from them, right? So you can't really see what I just wrote there because I'm going to be erasing it. But basically, this arc and this arc are kind of in line with angle 1, and so those are going to be the ones that are going to add up here, okay? So same thing with angle 2. That's going to equal 1/2 of x plus y. Okay? Because x and y are lined up, those arcs are lined up with angle 2 there. All right? Okay, if you'd like to try example 2 before we go through it together, feel free. But we're going to go through it in 1 second here. Feel free to pause the video. All right, so for example 2, we're looking for this angle x here. So yeah, we're finding this angle here. So we see we have the 140 and the 112. Those are lined up there, so we're actually kind of nicely set up there. We don't have to do much with that. So we can say, in this case, that x equals 1/2 of those two arcs added together there, which would be 112 plus 140. And that would be 112 plus 140 would be 252. And if we do 1/2 of that or divide by 2, we're going to get x is going to be equal to 126 degrees. And there's our answer. All right. Sounds good. I think we got to flip pages here. Sorry, they've made some updates to this thing here. So I'll go on the next page. Okay, this will be part 2 of 10.5. I apologize. I think I put them on in this document 2 separate pages, and that apparently makes different recordings. So this will be part 2 of 10.5. Another thing we have here is if the angles meet outside of a circle, okay? So a little bit of a kind of similar vibe, but a little bit different. So the way we like to talk about this, if we have this angle, like angle 1 here, I'll zoom in, it'll be a little bit more finer of a marker here. So this angle is going to be 1/2 of this big arc that's kind of in line with it, minus the smaller arc, like x and y here. Same thing over here, like this angle 2 would be x minus y, okay, 1/2 of that. Yeah, and that's basically it. Same thing down here, we got x and y, okay? So the trick is the angle, or angle 1 here, would be 1/2 of x minus y. So it's outside the circle, the angle's outside the circle, which it is. These are all outside the circle. It's going to be subtraction, and when it's inside the circle, it's going to be addition. Okay, but kind of the same thing where they're kind of lined up with it. All right. If you would like to try number 3 before we go through it, feel free. All right, for number 3, it says we have this tangent here, and it intersects outside the circle. Find the value of x. Okay, so this angle meets outside the circle here. So we know, it's kind of weird because it's like, we're using x for an angle here, but we're going to we can call this A and B then, similar kind of vibes here, right? So angle x is going to equal the big arc over here, which is 170. So actually 1/2 of 170 minus the other internal arc here, which is 72. Sorry, we got I'm in the LMC here recording, so hopefully it's not too loud. So we got 1/2 of 170 minus 72 is going to be 98. And that's going to equal 49 degrees. Okay, if you'd like to go ahead and try the checkpoints here, we'll go through them in 1 second. Number 3, try to determine like if it's going to be in, outside, or on the circle, and also be aware of what you're looking for because they might throw some little things in here to try to throw you off a little bit. So keep that in mind. Give them a try. All right, so for number 1, is this angle here, got this 120, is that going to be, sorry, let me zoom in a little bit more. Is this angle going to be on the circle, inside, or outside? It's on the circle. I'm just going to write that down so I kind of know. So I know it's going to be like the kind of like inscribed angle thing where it's half of that other arc there, right? This arc here. So we know the angle is half the arc is double the angle. We're looking for this arc here, so we're going to do what? We're going to multiply times 2, the 120 there, because we're looking for the arc, which would be 240 degrees. Nice. All right, for number 2, we actually have this arc here, which is x. They actually threw you off a little bit here, kind of goofy, and they're actually kind of mean. They actually like called this angle right here 52, which is not what we want. That's kind of pretty gross actually. So because the angle we need needs to be lined up with the arcs there. So in order to do that, first of all, like the angle we're looking for is, well, the angles are going to be inside here to start. Okay. Okay, so they're going to be inside there. So I'm just going to write 52 degrees, not what we want. Okay, the angles and arcs have to be all lined up here, okay? So we know this is 52 over here. What would this angle be up here? Well, we would do 180 minus 180. This is a linear pair right here, right? Kind of these two angles make a linear pair when they kind of go outside there, so you don't, if I erase it, it kind of goes away. So minus 52 is going to equal 128. So we know this is 128. So now what we have is we have all the angles and arcs lined up here. So a little bit funky. I apologize. This is kind of hard to read here. I'm also trying to, it's kind of loud in the LMC here. So, so what we know is the angle equals half of the arcs added together here. But in this case, we actually know the angle, which is 128, equals 1/2 of the arcs added together, which is going to be x plus 144, right? So actually they did some extra mean things here for you. Okay, so we have to solve for x now. How do we get rid of that 1/2? I would do times 2 on both sides. It's kind of like it was over 2 is you're going to cancel. 2 times 128 is 256. Equals x plus 144. How do we undo the plus 144? Minus 144. So we're going to get x is going to be equal to 112 degrees. So that was a mean one because they like gave you the wrong angle. It's not lined up with the arcs, and they also had to find the angle. Then they had to like find an arc instead of an angle. So a little bit trickier there with that one. But all right, number 3. We have this angle right here is 26. Is that going to be on the circle, in, or outside the circle? So it's going to be outside. Okay. In this case, though, so we actually know the angle. We're actually looking for this arc right here, which is y. So kind of the setup here is we're going to do the angle equals 1/2 of these two arcs subtracted. So a little bit trickier here. We have 26 equals 1/2 of y is the big arc minus 30. Okay. All right. How do we undo this 1/2? We do times 2. So 52 equals, these cancel, y minus 30 plus 30. And we get y is going to be equal to 82 degrees. Okay, so different formulas here depending on where they are. Also be careful, like usually the arcs have to be all lined up here, or the angles have to be all lined up, and the arcs have to be lined up here for the inside-outside ones. The on ones are kind of like one of the previous lessons in chapter 10, which is not as bad. But yeah, that's basically, I think, the whole lesson here. So we'll leave it there. Thanks for watching, and have a good day.